We're going to do Kramer's rules. So you just took a quiz a couple days ago over that. Some of you did great. Some of you need to practice it a little bit more. But all we need to do is, first of all, what? How do we start? Put them in the box thing. So we're going to find a determinant, a box thing, for the x and y coefficients, right? So 2, 3, these are my x's, these are my y's, negative 4, 2. Please watch the negatives. Some of you accidentally leave those out, and of course that changes your answer. Makes it wrong. All right, so let's see. This box thing, which we call a determinant, would be 4 minus negative 12. Watch your arithmetic. 4 minus, always minus, in this case negative 12. So my answer, which is going to be written exactly the same way as the last two were written, is going to be something over negative 16, or excuse me, positive 16. Right? Now where do I go?
Fill in the 1 and negative 2 and the x and the y.
These become now the replacement columns. And to find my x, I'm going to replace the x numbers with that. So I'm going to put 1, negative 2 here. These are my x replacements. And then my y's will be negative 4, 2. So what does that equal? 2 minus 8, which is negative 6. Now I'm going to come back and reduce that in a minute, but that's x. And then to do y, we'll do exactly the same thing, only we will replace the y's. So we'll have 2, 3, and then 1, negative 2. Negative 4 minus 3, negative 7. So your final answer, 6/16 would be 3/8 negative, and then 7/16 can't do anything with. So that is your final answer. That was going to be a little harder to check. You will have a calculator, so you could check it. All right, now we got the next page. Oh, we had a quiz like this too, didn't we? And what do we know about this page? Some of these might turn out to have no answer, depending on the situation. All right, so A says 2A. Doable?
Yes.
Always doable, kids. Scalar multiplication, multiplying by a number, is always doable. So we're going to have what? Top row? 2. 4.
6.
Perfect. Second row.
-2. 2. 0.
And bottom row.
0. 6.
2.
Okay, we're not going to miss that one. Right? No missing that one. Everybody gets that one right. Okay, B minus C. This is not always doable. There's B minus, here's C. Is that doable? Can I do that?
Yes.
I absolutely can, because the rule for addition and subtraction is they got to be the same size. They have to have the same dimensions. This is a 2 by 2, that's a 2 by 2. I can subtract them. So, one term at a time and one position at a time. 1 minus negative 1.
2.
Negative 1 minus 1. 2 minus 0. 3 minus 2. Let's not miss that either. That should be easy.
So when we're supposed to write it on the line, do we just put that matrix or?
That
Okay.
matrix goes on the answer blank, yep.
Okay.
All right, what about C? A plus B.
No solution.
Not doable, no solution, empty set, not possible, can't do. Whatever you want to write that indicates you can't do it. And why can't we do it?
Because they're not the same size.
They're not the same size, and you can't add them if they're not the same size. Does anyone have a question about that? Adding and subtracting, they have to be exactly the same size. All right, D times A. So this is going to be negative 2, 1, 4, 0, 1, negative 1, times A. I hope it's possible after I wrote it all out.
Yes.
What are the dimensions of this is D times A, and notice I'm doing it in that order. I wrote D first.
3 by 2.
What is this one?
2 by 3.
2 by 3. 2 rows of the bleachers, rows go sideways. 2 things are going sideways. 3 columns, and the dimensions of this? 3 by 3. This is a multiplication problem, and the rule for multiplication is that these two match. They do. So my answer will be the leftover dimensions, 2 rows, 3 columns. And to get these, this is a multiply problem. So I'm going to be multiplying each row by each column. I have to stay organized, so I'm taking the first row times the first column, and that's the number that will go in this spot. First row, first column. So to multiply, I'm going to take these numbers, negative 2, 1, 4, and I'm going to multiply them by these numbers, 1, negative 1, 0. So let's see, when I multiply each pair and add them up, it looks like I get negative 3. Bless you, excuse you, or whatever
That's
that
a
is.
hiccup.
All right, now we're moving over here to this spot, which is still in the first row, so I'm still using negative 2, 1, 4. But now I'm using this column, so I'm using 2, 1, 3. So I'll multiply each pair and add them up. 12, 13, 9. Is this bringing back memories, people? We getting this?
Yeah.
Now, for the third time, I'm going to use that top row. But now I'm going to multiply it by 301. Negative 2. Now what? Drop down. I go to the next row, and I do exactly the same thing. So I take my 0, 1, and negative 1, and I'm going to be multiplying it 3 times. I'm going to be using that row 3 times. I'm going to be using that bottom row with the first, second, and third columns. So there's my bottom row times my first column, my second column, and my third column.
Negative 1 is the first one.
First one's negative 1, okay?
And then negative 2.
-2 and what?
-1.
Some of us miss some of those. On the quiz. Do your arithmetic carefully. Everybody all right? All right, E. Oh, we had a quiz over this too. What does this mean? What am I looking for? I'm looking for the inverse, and this is my matrix. So who remembers what I need to do first when I'm looking? The determinant, exactly. So what's my determinant going to be? My determinant will be 3 minus -2 or 5. 3 minus -2. Now I just hold that number for a second, right? Jordan?
Then you flip the 1 and 3.
So I go back to my matrix and I put the 3 here and the 1 here. Like he said, these two flip, right?
And then you change the signs for -1 and 2.
So this one stays, 2 stays right here, but it becomes negative. 1 stays here, it becomes positive.
And you divide all by 5.
And divide all these by 5. And if nothing reduces, that's it, right? And since nothing reduces, that's it. A times C doesn't work because what are the dimensions of A?
2 by 3. I mean 3 by
A,
3.
3 by 3.
2 by 3.
And C is 2 by 2. Not possible, right? Can't do it. Empty set. Next page. Oh, we got a big determinant. Who remembers what we do here? We write the first 2 columns out to the side.
First two?
Yep, first 2 columns. Yep, not making that up. That's what we do. So 5, 0, -2, and 1, 3, 1. Make sure I copied it right, because that can be bad. All right, and then we start multiplying. So here I get -15, -4, and 0. So I got a -19 total. Don't let me make a mistake. Then I turn around, I'm not done. I turn around, I go this way. That would be 6. And that would be 10. And that would be 0. So I got 16. Now I subtract them, so -19 minus 16, -35 is the answer to the question. Now we got some vocab. Whoa, that's awesome. What are the dimensions of this matrix? 2 by 4. 2 rows, 4 columns. You just write 2 by 4. If this is matrix A, what would this be?
2 by 1.
No. Uh-oh. That means the entry in matrix A, the entry that is in the second row, first column. So the entry that's in the second row, first column is 5. You might want to go back and look at your notes. We talked about all this vocabulary. In the expression 2A, where A is a matrix, 2 is called a? No. What's the matrix word for real number? Physics people. Scalar. It's called a scalar. Again, The reason we take these notes is to study them. You guys better go back. It would be a shame to get a bad grade because you didn't know the vocabulary. What's a square matrix?
It has the same numbers.
It
The dimensions are the same.
Okay, so it has the same number of rows as columns. So it has the same number of rows as columns. A square matrix is a matrix that has the same number of rows as columns. I'm going to write the definition for matrix up on the board one more time, but then I will have written it twice, once in your notes and once now. After that, it's on you. If it's on the practice test, what do you know about the real test?
It's all in the real time.
Yeah. So what's a matrix? A matrix is a rectangular array of numbers. Arranged in rows and columns. If you look at practice test 2 and practice test 3, you're going to see that question asked. But I'm not going through it again. We know what it is. We know we need to memorize it. It is a rectangular array of numbers arranged in rows and columns. Okay, next page. Oh boy. Here's the big one. All right. So there's the chart, just like I promised you would be there. This time, we are making hamburgers and hot dogs. We got number, fixed interval, that's a little bit different. We'll talk about that. You'll see what it means. And profit. Now the chart's set up for you. We need to know what we're going to max or min. And then we need to draw the picture. Okay. Okay, now you need to be able to fill in the chart. So let's read through and see if we got some numbers. To stay in business, we have to sell at least 10 hamburgers, but we can't cook more than 40. Now, we've not had a problem that said things like that before, but you can make sense of that. If we let's let X be the number of hamburgers and Y be the number of hot dogs. Tell me about X. I have to sell at least 10, but I can't cook more than 40. What does that mean about X?
X is greater or equal to 10 and less than or equal to 40.
That is perfect. And do you see that as an interval?
Yeah.
That is like an interval. In fact, if you wanted to write it as an interval, it would look like this, wouldn't it? Isn't it the interval of numbers between 10 and 40? And you include those, so if you're coloring it on the number line, this would be the interval you're talking about, right?
Yeah.
Now, if you don't want to write it that way, it's fine. You can also write it the way Jordan said it, which is this, if that makes more sense to you. You can write it that way. That means the same as this. I don't care which way you write it whichever way makes sense to you. But the problem clearly says that X has to be between 10 and 40. Now, does it say something similar about Y? 30 to 70? So I'll write this one the other way. So 30 less than Y less than 70. Or if you prefer, you can put it in an interval also. Now we're going to be graphing those in a minute. We'll talk about that. But that's what we mean by the fixed interval.
Can we put those equations as the equations?
Oh, those are going to be the equations, yep. Now, it cannot cook more than 90 sandwiches altogether. So the number of sandwiches cannot be more than 90. 90 is not a fixed interval. It's not going to go here. 90 is the number, the total number of sandwiches is 90. The profit on a hamburger is 33 cents and a hot dog is 21. How many should I make to maximize profit? So my profit equation will be what? What am I going to write on that line? Exactly, done, stop, that's it, that's your profit expression, and we are not gonna graph it.
It's 21, not 31.
Oh, thank you. That would make a difference, wouldn't it? Now, we're not graphing that one. What are we graphing? Well, we know X and Y have to both be bigger than 0, so we'll just put those down, because even though they're even not part of this problem really, they're automatic points, let's just write them down. What else are we writing down?
Those two.
So X has to be between 10 and 40. Y has to be between 30 and 70. And kids, there's one more.
X plus Y has to be less than or equal to 90.
X plus Y has to be less than or equal to 90. Because the total number of sandwiches I'm going to make have to be less than or equal to 90. So that row gives me an equation, and then each of these gives me something to graph. All right. Shall we use the scale of 10? I think that's appropriate.
Fair.
So this one's easy. Let's graph this one first. So X plus Y, obviously if I let X be 0, I get 90. If I let Y be 0, I get 90. So I'm gonna plot 1, 2, 3, 4, 5, 6, 7, 8, 90 here. And 1, 2, 3, 4, 5, 6, 7, 8, 90 here. And then I need to connect those with a straight line. And it would be shaded below. So right now, my feasible region so far is this triangle right here. Now I'm going to do this one in purple. Now notice that one only deals with X. It doesn't have an X and a Y both. It only deals with X. So my points are going to be on the X-axis only. There's no Y's. So I'm going to come over here and it says X is between 10 and 40. So I'm going to draw a nice vertical line right down through 10 and a nice vertical line right down through 40. And I will be somewhere in between them. Would you agree?
Yes.
So I am in between those two. So I'm in the triangle, in between the purple. So would you agree we're looking at this chunk now? Now, the last one I have to graph does not have an X in it. It's only Y's. So these points are going to be on the Y-axis. So Y is going to be 30 and 40, 50, 60, 70. And these lines are going to go this way. Would you agree with me? And where am I shaded? In between them. Did that just stand? Or was that somebody else's?
That was probably someone else's.
Okay.
It's still going.
in between them. So now I'm looking at, kids, I'm under the red, between the purple, between the blue. So I am looking at a chunk that looks like this. Now yours probably looks better than mine because you just did a better job than I did when you got graph paper and stuff. But I'm getting that shape right there. So this time I have 5 points. Some of them are easy. This guy right here is easy. What's his X? 10. What's his Y? 30. So that's the point 10, 30. That's easy. This one, equally easy. What's his X? 40. What's his Y? 30. This one, equally easy. What's his X? 10. What's his Y? Easy. Now, actually, these guys are easy too, because see this point right here? He's on this purple line, which means his X has to be 40. And if his X is 40, then his Y has to be 50, because he's on the red line.
Ooh.
And they have to add up to 90. If you're on the red line, you add up to 90.
Yes.
So if X is 40, Y is 50. And then similarly, see this guy right here? His
20.
Y is
70.
70, so his X must be 20. So that one I didn't really need substitution elimination for because I had all those vertical and horizontal lines. All right, now what?
Plug it in.
Plug it into my profit equation. Then you got a calculator, you're gonna plug it in right here. So we're gonna take 0.33 times 10 plus 0.21 times 30. Oh my goodness, I'd work all day and make $9.60. I don't know. Tell me if I'm typing these in wrong. These numbers are pretty small. Do they? I don't know. Maybe I'm a spoiled, rotten rich kid, but I'm not sure I'd cook hamburgers and hot dogs all day for a profit of $23.70. Is that what you got? So what's the answer to the question?
40 hamburgers, 50 hot dogs.
Yep, I should make. Write a sentence. Don't whine and complain. You've done a ton of work. Don't stop now. I should make 40 hamburgers and 50 hot dogs for a profit of $23.70.
That's not a lot of money. There's no way I do that.
Believe it or not, kids, we have we've taken the whole test except for the calculator problem. So, huh? Yeah, we didn't do the calculator problem. We got a couple minutes. Let's get it done. Let's get your calculator problem done. Now, why did Mrs. Ford give you a whole page? Because you have to write down what?
Everything.
Not everything, but you have to write down the matrix that's going in
Matrix is
and the
in, out.
matrix that's coming
Out.
out. On the quiz you just took, I had that all set up for you, but that will not be the case on the test. The test's gonna look just like this, just a big blank space. So you need to write down the matrix that goes in and the matrix that comes out. So my letters are P, Q, R, and S. And sometimes I find it helpful to actually write those down, because can you see you're gonna have some zeros?
Yes.
So it might be helpful. So 1, -2, 3, -5, -34, 2, 1, 0, -4, -16, 0, 1, -1, -1, 1, 0, 2, 3, 0, -5. Oh my goodness. We really, really have to be careful, don't we? All right, you got that written down? All right, we'll finish that one tomorrow. Yeah, tomorrow, right? Yeah. And then, remember our test is Wednesday, so I need my calculators back. You got my calculators? Who else has my calculators? All right, we'll finish this next time. Have a good day. Bye. Bye. Have a good day.